Hey, geographers, you ready for a real challenge finally? Yeah, I know you are. I know you were just waiting for us to get to the difficult, difficult material. Good news, that's what we're doing right here. Now, look, this is stuff that sucks, and there's a part of me that just wants to throw you into it, watch you squirm a little bit so you can, so you can learn, you can grow and challenge yourself. I'm not going to do it because there's a lot going on here and a lot of stuff that I haven't fully gotten into yet. It's based off of some of the things we've done, but it's really taking it to the next level here. Okay, so what we're going to do is we're going to create some data for American Samoa, which is a small collection of islands out in the South Pacific. So I've created a new map. Just called it American Samoa in our GeoDatabase 220 map project. So I labeled that there. I zoomed out to get the big picture of the whole world, and where we'll be working is kind of over here-ish. And you could say on the edge of the map, although what we're going to see is that idea of that being the edge, it's a matter of perspective. We'll learn how to change that and how we're actually focused on the globe, right? Because the actual world doesn't look like this. You don't sail off the edge of the ocean and or suddenly show up on the other side like in a video game. It's a case where this is one way we've represented the Earth. So we'll play with that. But what we're going to do is based on stuff that I did years ago when I took on this project that involved doing some cartography as well as some analysis for American Samoa. And one of the first things I learned was out in the South Pacific, not a lot of GIS data is readily available. Like we'll have some very coarse data layers of boundaries, but they're horrendous, right? These are little islands that are meant to be shown at the scale of the entire Pacific Ocean, not zoomed in to one specific island or two. So I started with almost nothing when I took on this project. And so what we're going to do is one thing that I had to do, where we're going to look at some fishing vessel boundaries that we're going to derive from some government documents. And it's all very close to what we've done already, but we're going to go to the next level. We're going to make sure you have some cool tricks and some impressive skills once you get through this. And as I said, it's awful. We're going to go slowly. I'm going to have a series of videos here. This is going to be one assignment for the week, not multiple stuff, just to make sure that we're focused on this and you have enough time to play around with this stuff. All right. So we got the American Samoa map in here. If you go to Canvas and the whole files data thing, you can download this Samoa underscore fish .geodatabase zip file. And within there, you have the geodatabase as well as some PDFs with the actual data we're going to be creating, right? But I've added in, to make it easy, I copied this geodatabase file into the main geodatabase 220 project folder here and documents, all that stuff we've been doing. So I copied that there, and within here, I've given you 4 different feature classes. What I want to do to start out, since we're actually creating data, we're doing some legitimate work here. What I first want to do is project the data into a projected coordinate system. As they exist, they're in a geographic WGS 84 coordinate system, which is fine for just, to store these things, have it easily downloadable and all that. But for the work we're doing to ensure accuracy, we're going to, before doing anything else, project this stuff into this. Sorry, I'm spacing, thinking about the million different things we're going to do. We're going to project it an actual projected coordinate system. Okay? So to do this, let's first hit the drop down right here on our geodatabase 220, and we're going to do a new featured data set. Let it think. All right, so we got that there. Featured data set name. Let's do. Oh wait, caps lock got on. There we go. I'm just going to call it AMER underscore Samoa coordinate system. I want it WGS 1984, but not this whole web Mercator whatever. I'm going to click on this left thing right here, and Mercator works. Go to projected. Actually, let's do it this way. Let's do search, and let's type in Mercator, the last name of Gerardus Mercator, this ancient, what was he, 16th century cartographer. We'll just type in Mercator and hit enter. And then we don't want the layers, but projected coordinate systems. We've got national grids, world, and world sphere base. Let's do this world. Open it up. And we've got, let's do this one right here. Just the simple WGS 1984 world Mercator. Let's stick with that and hit OK. And let's hit run to create that. Now I'm going to go, yeah, let's go back to catalog. We'll make sure it's there. Okay, now what I'm going to do, I didn't really have to go back, but just to show you the idea, so we're going to do a batch project of admin, easy boundaries, all this stuff into our geodatabase 220. Okay, so to do that, I'm going to go back into geoprocessing, come out, wait, no, there we go. Come back here, and let's type in batch and project. And so it's the idea is we can project multiple feature classes at once. I can't remember if we've done that in here yet or not, but we're going to do it now. So let this thing think. Computer's struggling today, kind of like me at this point in the semester. All right, so batch project. Now what? Oh, because I didn't add them yet. Okay, whatever. So hit the folder. Okay. Go ahead and just, that'll open this up. Let it all load. You should see samoafish.gdb. Yeah, we got to double click there. And if I shift and select the top and then the bottom, it should grab them all. So that was, it's not clear. I select up here, hit shift, and click the bottom one, and it grabs all these. I'm going to hit OK. Yeah, that worked. Beautiful. So that's what I want to change. Then output workspace, I'm going to hit the browse again. Let it, because it's in here. I got to go back up to geodatabase 220. Double click in there. And I'm going to select that AMER underscore Samoa. Hit OK. Output coordinate system. I'm going to go ahead. I guess I have to hit that. Do I? I don't know. Just to do it, to make it simple again, type in Mercator. So that give me that. Yeah, okay. And just select this same one. I don't know if I have to do it or not, but we'll see. I'll go from there. Okay, I'm going to hit run. And then it's thinking, it's working. Hopefully it'll work, we'll see. These are big files, by the way. Probably could have clipped them earlier, but we'll make this work. This'll work. Here we go, did we do it? Gorgeous. We got a lot in here. Because these are files for the whole world that we're dealing with. But it worked. go back to catalog. And then within here, I should see these. And these should be my projected ones. To double check, I can right click and hit properties and go to source. All right, make sure it's kind of obnoxious, but it's showing that it's saved in that specific database. And which data set? This one that we wanted in, right? So that's one way to make sure that I'm dealing with the proper ones. And then if we come down, spatial reference, it has that WGS 84 World Mercator. So we're good. Beautiful. Okay, what I'm going to do, I'm going to uncheck lat long, because there's a lot going on here. I'll leave this stuff on as well. But go ahead, we'll just kind of zoom in to the right area. We're going to zoom into this part of the map. So I'm going to hit shift, do a little zoom rectangle around here. And this shape, to me, it kind of looks like a peep, like, around Easter time, those little marshmallow things. But that shape, that's where we're headed right here. And it's thinking, and if I click on one of these islands, it tells us that's American Samoa. Okay, I'm going to go ahead and hit save. Once I'm here, just to kind of save what I've done, and you can see we've got tiny little islands that make up this whole area. So all of American Samoa, it's multiple islands in here, right? And this is just Samoa next to it, to the west, right here. And then other little island nations and stuff all around it. Okay, so this is where we're working. Now, again, the idea is, I'm going to go ahead and zoom out. You don't have to, but this has us placed on the edge of the map right now, which isn't always ideal. Like one of the maps I had to do for this project was to show all of the South Pacific to give a sense of where this island is in relation to other island nations, as well as, Australia and North America, right, to situate it. As it stands, I can't do that right now, right? That doesn't work. So what we're going to do, before we actually do real work, this isn't crucial for what we're doing, but it's good to know, to see how you can mess around with this stuff. What we're going to do is change the projection that we're looking at. So in the map itself, we're not going to mess with these files here, but instead we're going to come into our actual map itself, and we're going to mess around with the way it's drawn, the way the world is projected here. So I'm going to right click and hit properties. All right, we're going to come down to coordinate system. And so it's using this one we've been using. And if I right click on here, I've got this option copy and modify. And that's what I want to do. And what this will do is it's saying, all right, it's not going to change the original coordinate system, but we're going to make a custom version here. And so this new window that pops up allows us to get in and mess with whatever. We can rename it, right? Which this _1 isn't really useful, but I could call it like WGS 84 World Mercator. Let's call it Pacific. That'll make sense. Leave this other stuff, okay? And the key thing here, we're not going to do much with this. It's not that hard. But this central meridian and standard parallel, these are things worth changing to alter stuff. What it's saying when it says central meridian is which line of longitude is it going to center on? What's going to be the center of the map? So 0 degrees longitude, that's the prime meridian. Runs through England, down through Africa. That's where we typically have these maps based. Parallel means latitude, so it's 0 degrees latitude, that's the equator. So the absolute center of the map is where the equator and prime meridian cross, where they intersect. right? We don't want that. That works for some stuff, not for what we're doing. We're going to flip it, and we're going to make the central meridian 180 degrees, okay, which is the international date line. Technically, it's that edge of the map. So we're going to take the edge, we're going to make that the center. That's the goal. Everything else I'm going to leave. I think with the parallel, I can't remember if I changed it for them. Not really crucial. I don't think. Maybe we'll change it. We'll see. But just change that to 180 and hit save. Now let's go ahead and hit apply just to kind of see. Make sure it's working. It looks like it's working. Gorgeous. So I'm going to go ahead and hit OK because I'm happy. And I'm going to scroll out. So there we go. Look at what we did. This is pretty awesome right here. It's taken a while to draw this stuff, and it's having to think. Not only is it all the data, but it can be a little tricky for this stuff to redraw. But what we've done is we've changed the focus, the center of the map, pretty simply, just by getting in and modifying the coordinate system that we're using. It is still drawing. And in fact, I'm going to go ahead and turn off. Let's turn off admin and EEZ boundaries. So I'll just have that EEZ polygon. I'll explain what that is in a moment. It's drawing, it's thinking. Well, what you'll notice, like right off of New Zealand right here, is there's this line. We have the seam running through the data, and that's just the fact that these data were produced using that more typical, map focused on the prime meridian and the equator. Not that big a deal for what we're doing, but if I were working, say, on, this New Zealand area, there's some ways I can kind of cheat with this stuff. Now let's just zoom in. Oops, hold on. There we go, maybe. Man, it's thinking a lot. So be patient when you're working on this stuff. See, is it still drawing? So yeah, we've got the lines running. It doesn't affect where we're at. But like one thing you could do, just to make it really easy, is get rid of the outline, right? Just hit apply. We'll sit here for an hour while it thinks. Look, I got rid of the outline. This should be easier. There we go. So the line vanishes at that point, right? Because there's no outline. So we have ways we can manipulate this, get a little creative. And then if that wasn't going to cut it for you, you might have to go in and create a new polygon for this thing. Go into editing, modify some stuff, try to dissolve some of these things, like whatever the solution might be. But again, not what we really need to do this time, so we're not going to stress over this. I'll turn these lines back on, which alleviates some of this problem too. So this, again, is where we're headed. Let's zoom in here. And I'm going to go ahead and turn off the background stuff. I'm not going to get rid of it because it might be useful. I've got that there. I'm going to turn on the admin layer. I'm going to hit save again. Okay. So here, I'll explain this easy stuff, and then that'll be it for this video. This is just this kind of starting point. And then we'll get into the government data documents and all that. Okay, so EEZ, all right, this weird blob thing. This is a crucial thing for what we're going to be looking at, but the EEZ stands for Exclusive Economic Zone. And so the idea is it's this sovereign territory in ocean waters that a nation owns and can, actually fish in, extract resources from, and all of that. So all throughout the world, wherever you have coastlines, it's a case where, and it's changed over the years, a lot of legal fighting over what exactly are we dealing with, but it's every nation has this exclusive right to their territorial waters, right, within specific distances and all of that. So that's what we're looking at. And so because American Samoa is an American, a U.S. territory, this weird little peep shape, that's ours. That's our turf, right? Samoa, this is their exclusive turf. And all these other nations have this exclusive stuff. And then where you don't have that, it means that's far enough out, that would be, international waters. That's the notion that even that term is kind of a fuzzy thing. But what we're going to do in the next video and going through this stuff is we're going to look at where certain boats, certain fishing vessels were legally able to go fish. All right, this was a big thing for the work that was being done, the research that this historian was doing, and she wanted a map of these boundaries and all that. And what I learned is these don't exist. Right, we can find EEZ stuff easily. This is other stuff that doesn't exist. Okay, so go through this, save this, pull up the next video, then we're going to get into the actual data and what we're dealing with. All right, good work, geographers.